Hi, it's Mr. Duffy. Welcome to our lesson today in chemistry. Today's lesson in this video is really to try and get you to understand how and the purpose for the electron drop worksheet. Electron drop worksheet is really to kind of show you the different transitions of an electron in a hydrogen atom going according to the Bohr model. So let's take a look at a simulation first to kind of try and explain what this electron drop worksheet is trying to show us. So this is a Bohr model of hydrogen. We've got one proton in the nucleus and one electron moving around in an energy level around the nucleus. So the lowest energy level, so we would call that its ground state. Now, we can give this electron energy by, again, exciting it to an excited state by two ways. One, it has to absorb a photon of light that matches up to the energy transition. Or, again, we could run electricity through it. So here I've got a little photon gun, or basically, again, a flashlight. And it can specifically give some photons of particular amounts of energy. Now, if we watch it for long enough, we can see that again, well, right off the bat, actually, the electron will absorb certain amounts of energy and then jump up to an excited state. You can see that happening over and over and over again. Now, when it's doing that, again, it jumps to a higher energy level and then immediately falls back down. And we can see this on the electron energy level diagram over here on the right side. This is basically what your electron drop worksheet is like. Okay, the electron jumps to a higher energy level and then it falls back down. And as it falls back down, it gives off photons. Those photons can be then collected by a spectrophotometer, and we can see those different electrons jumps, those electron drops on the spectrophotometer. And so that's what we're again making on our worksheet, kind of looking at those different drops, those energy level transitions, and seeing what types of light it gives off. Now this would take a while in this simulation, but if we look at another simulation where we are looking at hydrogen again, and instead of having a photon of light, like a flashlight, giving the electrons energy, the hydrogen atoms energy, we have a battery. And so here we have lots of hydrogen atoms inside this tube, and they're all getting some electricity, some energy from the battery. It's increasing their energy to an excited state, and then they're falling back down to different energy levels. They're electron dropping. We collect that information, again, using a spectrophotometer. We can see the different transitions, the different wavelengths that the light waves are given off. And we know from our worksheet last week that different wavelengths have different frequencies, and those different frequencies have different energies, and the energies correspond to what energy levels they fell from. So if they fell from the second energy level to the first energy level, again, that would have a different amount of energy than if they go from the third energy level to the second energy level. So that's again how Niels Bohr kind of found that out, how he found out where those different energy levels were. Now let's talk more about how to do this electron drop activity. Here we have some directions on the first page that, again, kind of give you a little information that I just kind of went over, but you'll still want to read that. And then there are some questions to answer in this first page. This last question, we're not going to be able to answer until we actually do the electron drop activity. So if I scroll down to this, or if I go down to the second page, we can kind of see the electron drop activity, and it's showing you the different energy levels. So the different first energy level, second, third, and so forth, just like the simulations that I was showing you. So these represent the energy levels around the nucleus. It's just, again, kind of on a landscape type of situation instead of a circle. Now, each arrow represents an electron drop from this first example. It's from the 7th energy level to the 1st energy level. So what we're going to be doing is we're going to be measuring those different drops, the different transitions, using the ruler on the right. So let me show you how to do that, Cami. The easiest way that I found is to create a line that exactly matches the transition. So we can again create that line that is exactly the same length as the one in the diagram. Then I can drag that line over to the ruler and measure it. Okay. So once again I do that, I can see this matches up, and if you zoom in, it kind of helps a little bit too. About 13.5 or 13.45 centimeters. Okay, so that would be the amount of energy that is involved in the transition from the seventh to the first energy level. And I can then mark that down here. So if I said it was 13.545 centimeters, I can mark that down here in, I'm going to do it in gray, on the chart on the bottom. I can enter text to say that was 7 to 1 transition, and that would be in the ultraviolet range. I can make it smaller too. Make the text smaller as well, and then it'll fit better. I'd probably make it smaller than that even. Now, I would continue this for each of the different energy level transitions, and I can just take the same line and adjust it and adjust the length of it to the next transition and the next transition and the next transition and so forth. So I can just drag that line back and forth to the ruler to make my measurements, and then I'm again marking them down here on the bottom diagram, kind of like that's basically what the spectrophotometer in the simulation. Let me go back to the simulation here. So basically, it's my wavelength spectrophotometer here, but it's not wavelength; it's energies that I'm representing. So I'm measuring the energies, putting it on the scale, and then again that would match up to certain wavelengths. So again, I'm going to do that for each of the lines, each of the arrows on the electron drop activity. That's going to give me some portion that's in the visible spectrum here, some lines that are in the visible spectrum right here on the graph. And then I'm going to match that up to one of these emission spectra that matches to hydrogen. So I'm going to get some colors again that are in the Roy G. Biv portion. I'm going to be able to answer that final question. So again, this is how electrons transfer in the Bohr model, and how to complete this electron drop worksheet. So if you have any questions, please send me an email, and thank you for watching.